Meghna Parikh, and today we are here to start the lecture series of Mathematics-02. Okay, our topic is unit step function and second shift theorem. Unit step function is known as also Heaviside function. Unit step function is defined as u of t minus a equal to 0 when t less than a and it is 1 if it is t greater than a. That means this area is between 0 to a. In 0 to a, this function value is 0 and this area is greater than a, so it is 1. This is a graph of the unit step function. Now, find the Laplace transform of unit step function. Laplace of u of t minus a. Okay. So, prove by the definition of the Laplace transform, Laplace of f of t is 0 to infinity e raised to minus st f of t dt. Okay. 0 to infinite e raised to minus st u of t minus a dt. But as per the definition of the unit step function, we take 0 to a e raised to minus st. There is a function in the 0 to a, it is 0 plus a to infinity e raised to minus st. In this interval function value is 1 dt. Okay. Now, next a to infinite e raised to minus st dt. So, integration of this e raised to minus st upon minus s a to infinite. So, it is 0 minus 1 upon e raised to minus as upon minus s. So, answer is e raised to minus as upon s is a Laplace transform of the unit step function. Okay. Now, second shift theorem. It is also depend on the unit step function statement. If Laplace of f of t equal to f of s, then Laplace of f of t minus a u of t minus a equal to e raised to minus as f of s. First of all, we are taking as a definition of the Laplace transform, Laplace of f of t minus a u of t minus a 0 to infinite e raised to minus st f of t minus a u of t minus a dt. But definition of the unit step function, we know that a value of this function is 0 when the p-value is less than a and it is value 1 when t greater than a. Okay. So, we take this value as a 0 and f of t minus a, because we are taking here u of t minus a value. We are taking 0 and 1 time is 1. So, our integral is converted into a to infinite e raised to minus st f of t minus a dt. Now, t minus a equal to, we are supposing u. So, t equal to a. T equal to a plus u, dt equal to du. When t equal to a, u equal to 0, t equal to infinity, u equal to infinity. Convert this integral, we get 0 to infinite e raised to minus s a plus u f of u du. We are taking e raised to minus as common because it is a constant with respect to u. So we get e raised to minus as 0 to infinite e raised to minus su fu du, and this is the Laplace transform definition. So we write as f of s. So answer is e raised to minus as f of s. So this is a proof of the second shift theorem. Now find Laplace transform of e raised to minus 3t u of t minus 2. Okay, so there is one corollary from the second shifting theorem. Corollary say that Laplace of f of t u of t minus a, we take e raised to minus as Laplace of f of t plus a. Okay, so for this we take Laplace of e raised to minus 3t u of t minus 2. Okay, so we take e raised to minus 2s Laplace of f of t plus 2. But in that case, what is our function? Function is e raised to minus 3t. So it is t plus 2. E raised to minus 2s and e raised to minus 6 is common because it is a constant. Laplace of e raised to minus 3t. So answer is e raised to minus 2s minus 6 upon s plus 3, because Laplace of this function is 1 upon s plus 3. Again, from the second shift theorem, we have deduced one corollary. If Laplace of f of t u of t minus a, so we get e raised to minus as Laplace of f of t plus a. We are comparing this example with this corollary, then we get this is your f of t and this is your u of t minus a. So what is a? A is a 2. So we take e raised to minus 2s Laplace of f of t plus a, f of t plus 2. But here function is e raised to minus 3t. So we are replacing t times 2, t plus 2. So we are taking e raised to minus 2s, e raised to minus 6 as a constant common. Applying Laplace of from the e raised to minus 3t, so it is e raised to minus 2s minus 6 upon s plus 3. Find the Laplace transform t square u of t minus 2. Similarly, Laplace of f of t u of t minus a, we are taking Laplace e raised to minus as Laplace of f of t plus a. Okay. So here example t square u of t minus 2 e raised to minus 2s Laplace of f of t plus 2 f of t plus 2. Okay, e raised to minus 2s Laplace of our function is t square. So we take t plus 2 whole square. E raised to minus 2s Laplace of t square plus 2t plus 1. E raised to minus 2s, answer is 2 factorial s cube 2 upon s square plus 1 by s. Answer. Okay. So this is the second shift theorem and unit step function application. Thank you.